Okay, students. So, as you know, the forenoon session for GATE Mechanical 21 has occurred in yesterday's morning. So, we would like to give the answer key in a quick shot because at this point of time, many of you might be waiting for the answer key for different questions. So, we got some 47 questions with us collected from our students who have given the exam. So, definitely we would like to reveal this key for all the 47 questions. Okay, because detailed solutions is not of much importance at this point. So, I would like to straight away give the key. So, in the forenoon session, straight away, if you start, we have one question from the heat transfer that they are asking that to read the data from the Heisler charts, we need what are the dimensionless numbers we need? We need basically this Biot number and the Fourier number. So definitely this Biot number and Fourier number is the two numbers that we need to read some data from the Heisler charts. Correct? Yes. So this is what we have, of course, and along with this few other options are also given: Prandtl number, Nusselt number, and all these things. But of course, these are the two numbers. You might be remembering this term, exponential of minus Biot number into Fourier number. This is what we'll be having in the time analysis of this lumped system analysis and all these things. So definitely we can read some of this data, read data from this charts using this Biot number and Fourier's numbers. Okay, this is first question. So for the questions which have different options, this option involving Biot and Fourier is the correct answer. Next, they have given some question from the relative humidity. So they have given like for the relative humidity phi is equal to 50%. And they have asked the relation between vapor pressure and the vapor pressure at the saturation state. And you know, this phi is nothing but the ratio of these two. So PV by P sat, this value is given as 1 by 2. So 1 by 2 is equal to PV by P sat. So this implies your PV is equal to 0.5 times saturation vapor pressure at the corresponding temperature. Correct? So this is what we have, and of course this is 0.5 times of the total or the saturation vapor pressure at that particular situation. Okay, so this is one question that you have, and this is the correct option. And of course for this question there are many other options, taking PV is equal to P sat, PV is equal to 2 times of PV sat and all, but of course this is the correct answer. Anyhow, let's go for the next question. Yeah, there is a gas filling. Of course they have given you the open system where there is a valve and that's filling a gas into a container, and the situation of the gas inside this is TIPI, and of course if the container is now completely filled by the same gas, then what is the final pressure or final temperature when it is loaded to the same pressure, Pi? So when it is loaded to the same pressure, Pi, then what's the temperature here? This is what the question. So we know the final temperature in the side of the gas will be equal to gamma times of this initial temperature. So we can write this Tf is equal to, since the substance inside this is given as A, gamma can be taken as 1.4, and this Ti value is given as 400 Kelvin. Yeah, this is 400 Kelvin, correct. So 400 times this will give you 560. So the final answer for this is 560 Kelvin. Okay, so Tf is equal to 560 Kelvin is what we have at this point. Okay, so this is the answer for this question. Then we have one question from mathematics also. So they asked you for what's the value of limit x tends to 0, 1 minus cos x by x square. So if you apply the L-Hospital rule, and it's a simple question, the answer for this is 1 by 2. Okay, because I told you the general case also in our classes many times. If you have this 1 minus cos ax divided by x square, the answer for this is a square by 2. And in the exam, they have given you the value of a as 1. That's it. So the answer for this question is 1 by 2. And since this is some numerical answer type or something, you can answer 0.5. Clear? So this is what we have one question. Next, we have one more question from mathematics. They are asking you for Laplacian of delta. So delta of t minus a. So this is what they have given. And of course, the answer for this is e power minus as. Okay, it's just they have given you one property of this Laplace transform of this function. So definitely Laplace transform of this function, as long as this a is positive, is nothing but e power minus at. And how did you obtain this e power minus as? This is nothing but e power minus st at t is equal to a. So if you substitute t is equal to a, e power minus as is what you will be getting. So that's the answer. Clear? So next we have one more question from mathematics from the mean value theorems. So f of x is equal to x square plus x, minus 2x plus 2 is what it's given in exam, and the interval that they mentioned is 1, 3. So definitely if this is the interval, so you know if this is a quadratic function, then it depends only on the initial and final limits of the interval. So the mean value is nothing but the average of these 2 points, 1 plus 3 by 2, which is 2. So 2 is the point of x, x is equal to 2 is the point at which the tangent to this curve f of x will be parallel to the line joining this 1 comma f of 1 and 3 comma f of 3. Okay, so that's a simple question which we have already discussed in the class many times. So the answer for this question is 2. Okay, so the answer for this question is 2. Next, let us go for the next questions quickly. Yeah, there is one question from fluid mechanics, assuming this simple Corti flow. So if you have a plate fixed, and of course this plate is moving with certain velocity, and they have also given there is no pressure gradient in this direction. So dou p by dou x is equal to 0, and this clearance between the height or the distance between the plates is also given. So whenever there is no pressure gradient, you know the velocity profile assumes linear in case of a simple Corti flow. So you can just trace out a linear velocity profile. If this is a linear velocity profile, then you can write u is equal to capital U into y by h. Of course, my directions are, this is x and this is y. So in this case, if the pressure gradient is linear, then you know the shear stress is nothing but mu times of dou u by dou y, or the average shear stress you can write. So u into, if you differentiate this partially with respect to y, you will be having u by h. So mu u by h. So the values are given. Mu is something it's given, 1.25 into 10 power minus 4 is the kinematic viscosity. So this has to be multiplied with the density into velocity is 4 meters per second. Okay, and the clearance between them is 5 into 10 power minus 3. So if you quickly perform this calculation, you will be ending up with 80 pascals. Okay, so this is what the average shear stress that acts in the direction of this fluid flow. So 80 pascals is the correct answer for this question. Okay, and I hope many of you have solved it correctly, because this is straight away the question which is simple. Next, in thermodynamics we have one more question, at least one isothermal process. So in the options, if you see, they have given you Carnot and Stirling cycle. In both the cycles, the heat additions and heat rejections are isothermal. So definitely there is at least one isothermal process in this case. But if you go for the other options, Otto and diesel. In Otto and diesel, compressions are adiabatic, but of course heat transfer process, basically heat addition and heat rejection processes, are not isothermal. Similarly, in Brayton and Rankine cycle, in the Rankine cycle you don't have any isothermal process. Of course there is a phase change, but of course in Brayton cycle you definitely don't have any isothermal process, because in Brayton cycle, if you try to quickly recollect this TS diagram, there's isentropic compression, then constant pressure heat addition, and of course then isentropic expansion, and again constant pressure heat rejection. So these are constant pressure process and these are isentropic process. Of course, if you assume reversibility, then these are isentropic. Actually they are adiabatic process. So this is Brayton cycle. So Brayton cycle. So of course these are the only two cycles in which there is at least one isothermal process. Clear? So this is what we have. Again, there is one question from compressibility factor. So in compressibility factor, they have given you Z, P. So Z is equal to 0.95 is given, and P is equal to 1500 kilopascals. And they have also given you the molar specific volume, V bar is equal to 2.75 meter cube per kilomole. This is what the data we were given, and they are asking you for the final temperature. So it's a simple approach. We can write PV is equal to Z times N RU T, where RU is, the universal gas constant, and if you divide this with 1, we have P into V bar is equal to Z into RU into T. And out of these 5 quantities here, we have 4 quantities, 1, 2, 3, and of course RU is a constant, universal gas constant, which is 8.314 kilojoule per kilomole Kelvin. So if you substitute all these things, your answer for temperature should be something like 522.26 Kelvin, and which is also equivalent to something around 249.11 degrees Celsius. Okay, so this is what the final temperature that you have for this question. Okay, so if you enter something in between around 249 or 250, that could give you a correct answer. Fine. Next, let's go for the next question. They have given you one more question from mathematics. Cyclic integral over C cos hyperbolic 3z divided by 2z. Of course, this integral has to be dz again, and this integral has to be evaluated using this unit circle, along this unit circle. So if you solve the answer by using residue theorem or by simple expansion of cos h 3z and all, you'll be ending up with the answer as pi times of I for this. Okay, so pi I is the value of this integral when evaluated using along this path. Okay, so the answer for this is pi times of I. Next, there is also one more question from differential equations, which you could write sin x into dy by dx plus y times of cos x is equal to 1, and the boundary conditions are given as y of pi by 2 is equal to pi by 2, and they are asking you for the value of y of pi by 6. Okay, so this is what they are asking you. It's a simple linear Leibniz equation. If you just perform one step, dy by dx plus this sin x, if you divide throughout the equation, we get y into cot x is equal to cosecant x. So this is a Leibniz linear equation which is of the form dy by dx plus y into p of x is equal to q of x. So if you solve this and apply the boundary conditions, the answer for this question you will be ending up as pi by 3 is the answer for this. Okay, it's a simple Leibniz linear differential equation and you could solve it easily. And the answer for this at the end will be pi by 2. Okay, yeah, sorry, pi by 3. Yeah, pi by 3 is the correct answer. Next, they have given you one reheat Rankine cycle. So let us quickly try to draw a reheat Rankine cycle. If this is TS, so let us try to quickly draw a Rankine cycle 1 to 2. Then we have some high pressure turbine expansion, again ideal Rankine cycle. So let us suppose this is the cycle that we have. Okay, so this is the reheat portion that we have already, and they are asking you for the Dyna's fraction at this point. Correct? So they are asking you for the Dyna's fraction at this point. What is the x? Of course, they are asking you in percentage. This is the case, and of course they have given the high pressure turbine work is 750 kilojoule per kg, and of course this low pressure turbine work is 1500 kilojoule per kg. and the pump work input is 20 kilojoule per kg. So this is the data that is available with us, and of course they have also given the HF value at this point is 200 kilojoule per kg, and this Hg value at this stage, is equal to 2600 kilojoule per kg. So this is the data available with us, and they have also given you the thermal efficiency of the cycle, complete cycle, is equal to 1/2. Okay, so if this is the thermal efficiency of the cycle and if this is the data, then you will be ending up with this dryness fraction as 92.99%. If you round off to nearest integer, this x is equal to 93%. Okay, so 93% is the correct answer for this, and 93% is the dryness fraction of the steam that's expanding from the low pressure turbine. Is that clear? And of course, calculations are pretty much simple for this. There is no issue actually. Since efficiency is given, we can easily calculate the difference between the enthalpies of these 2 points, and you know the enthalpy of this point by calculation. So definitely you could get the enthalpy of this point. And if you know the enthalpy of this point, since you know HF and Hg, you can calculate dryness fraction. Okay, that's a clear thing. Next, let us go for the next question quickly. Yes. So there came one question from the shape factor. So they have asked if there is some cube. So there is some cube here, and of course there is also some sphere inside this. So if this sphere is taken as surface 1 and if the inner surface of this cube is taken as surface 2, then what is the shape factor? F21. That's what they are asking you for, correct? Sorry, F22 is what they are asking you for. So F22 is equal to how much? This is the question, and of course if you apply the reciprocity theorem, and of course if you apply this F21 plus F22 is equal to 1, which is the summation principle, and of course if you apply this A1 into F12 is equal to A2 into F21, then since this F12 is 1, because whatever the heat that gets radiated out of the surface, there is no chance that again the heat gets radiated back onto the surface, so it just radiates onto the cube. So this F12 is 1, so F21 can be calculated as ratio of A1 by A2, where A1 is the surface area of the sphere, and of course A2 is the surface area of the cuboid. So R is given, A is given, R is given 10 centimeters, I think. Yes, R is 10 mm, and C or L, this is equal to 30 mm. So this is what they have given you, and of course if you calculate the final value, you will be ending up with the answer as F22 is equal to 0.767. And in the exam they have asked you to round off to 2 decimals. In just you can write 0.77. That's okay. Clear? So this is what we'll be having for this shape factor question. Next, let us go for this heat transfer fin question. So in this heat transfer fin question, what they asked you for, we know whenever we have attached a fin, an infinitely long fin, of course. So if you attach an infinitely long fin and if this fin is conducting to the atmosphere, then the heat loss is equal to root of Hp K AC into theta naught, where theta naught is the difference between this root temperature and the ambient temperature, and of course AC is the cross sectional area of the fin, and then K is the thermal conductivity, P is the perimeter, H is the heat transfer coefficient for this interface, correct? So if H is the heat transfer coefficient for this fluid fin interface, then definitely you know this is the Q dot. Of course this is the case when infinitely long tip or infinitely long fin. Then in exam they are asking you Q dot 1 is the case of root Hp K AC theta naught, and in Q2 dot what did they change? In the second situation they have changed the fin material, and the thermal conductivity is 2 times of this actual existing material. So if this is the case, then you could clearly see this ratio Q dot 2 by Q dot 1, this is equal to root 2. That's it. So square root of 2 is the factor of this ratio, because the heat transfer through this infinitely long fin is root Hp K AC theta naught. Okay, so this is what we can have. Next, we have one question from this thermodynamic properties. So du is given as TdS plus tau dL, and of course we know this internal energy is a property. If internal energy is a property, then U is an exact differential. So for this to be an exact differential, we know if you have mdx plus ndy is equal to dz, then for this z to be an exact differential, we have dou m by dou y at x is equal to constant is equal to dou n by dou x at constant y. So if you similarly apply for this, we have dou t by dou l at s is equal to dou tau by dou s at l. Okay, this is what we have, and in the exam they have given you what's the value of this dou t by dou l at s. It's nothing but dou tau by dou s at l. Okay, so this is one of the options. If you could verify quickly, it's present in your exam. Next, let's go quickly for the Pelton wind turbine, simple Pelton turbine. So in case of the simple Pelton turbine, they have given you the inlet conditions and of course the deflection of the jet. So that the jet is deflected by 165 degrees in a total. So if the velocity v1 is in this case and also the u is also in this case and the diameter of the wheel and everything is given. So they are asking you for the finally power developed by this Pelton wheel. So the power value, if you make quick calculations, this is nothing but 2.680 kilowatts. It's megawatts, sorry. This is in megawatts. So this is the power developed by the Pelton turbine for the given situations in the exam. So definitely this is the answer. 2.680 megawatts is the answer for the simple Pelton turbine. Next, let us go quickly. Then there is one question from fluid mechanics also again. So they are asking you, a submarine is going at certain depth below this free water surface. So if the submarine is moving at this depth, then the pressure reading here, P absolute, this is given as 4.2 megapascals. And of course the atmospheric pressure, P atmosphere, this is given as 101 kilopascals. And they are asking you what is the height or what is the depth, let us call this as depth. What is the depth at which the submarine is moving? Suppose if this is submarine, okay, so at what is the depth at which submarine is moving? So they are asking you for this depth. So basically if you apply the simple pressure balance, you can get 4.2 into 10 power 6 pascals minus, this is absolute pressure. So this is equal to 101 kilopascals, which is 101 into 10 cube pascals plus rho GH. And of course it's given water. So 10 cube is the density of water. Acceleration of due to gravity is 9.8 into depth. So if you perform this calculation, you could get depth as 390 or something. Let us check the calculation quickly that we had in last day. So 398.4 meters. So 398.4 meters is the depth at which the submarine is moving. Okay. So generally, submarines move at in between 300 and 400, some highly sophisticated turbines. So definitely this could be a reasonable answer for us. Okay. So 398.4 meters is the depth at which this submarine is moving. Next, we have this one question from fluid mechanics again from the impact objects. So basically we have a channel. Okay. So basically we have some, let us try to frame this. So we have a spring which is attached here and there is some deflection in the spring when there is a water jet that's striking here. So a water jet is striking like this. So there is some water jet that's deflecting this, that's trying to exert some force on this. Numerical method questions. Yeah, I'll discuss everything, Sai Krishna, no issue. So please be focused. So see here, if this is the case, then yeah, dimensions are given. So the diameter of this jet is 1 centimeter. What are the other quantities given? And spring stiffness is equal to 1 kilonewton per meter. And of course, the deflection in the spring is 1 centimeter. So, just if you apply the momentum balance, your sigma F that's compressing this, which is Kx, this should be equal to the net force applied by this jet on this plate. So, which is O times A square, where A is the area of Z. And they are asking you for the velocity at which this jet should pinch on to this balance. So, definitely if you calculate, you get V is equal to 20 by root pi. Yeah, this is the calculation that you obtained, and if you punch a couple of keys in the calculator, this is 11.28 meters per second. Okay, so this is what you have for this answer, velocity 11.28 meters per second. Okay, so 11.28 meters per second is the velocity at which this fluid jet has to impinge on this plate so that the spring having a stiffness of 1 kilonewton per meter will deflect by 1 centimeter. Clear? I am just giving you the answers at this point straight away. Detailed solutions we are not mentioning, how this is OA V square and all, because that's of interest till yesterday. Next. Yeah, there is one question from the triple point situation again, NH3 they are talking about. So, if you try to draw the triple point in this PT curve, then definitely we have some curves meeting here where solid region, liquid region and all the things are present, but of course at this point I don't like to give all these things for you. So generally you have solid vapor, solid plus vapor and all these things, but of course in the liquid vapor interface they have given you the pressure ratio, or the pressure is related to temperature by this equation 24.38 minus 3063 by T. This is what we have, and of course this is in the liquid vapor region. Okay, and in the vapor solid vapor region, this is also given as ln P is equal to 27.92 minus 3754 by T. So this is what we have. So at the vicinity of the triple point, these both pressures are same, because triple points are generally having fixed situations, and in the vicinity of this triple point in both the situations, these pressures remain constant even though the temperatures remain constant, but they are asking you for the temperature, so you can equate the right hand side of both these equations. So if you equate the right hand side of both these equations, you have some equation like 24.38 minus 3063 by T. This should be equal to 27.92 minus 3754 by T. So if you solve this equation for T, you will be ending up with the T value as 195 Kelvin. 195 Kelvin. Okay, so this is what we have. Next, for the forward Newton iteration scheme, forward Euler's iteration scheme, the forward Euler's method is given by yi plus 1 minus yi divided by h is equal to some lambda times of yi, or some function in terms of y and x, dy by dx. So this is what we have, and of course I told you clearly in the mathematics class, in the comprehensive course, and also in the PYQ series. If you just look carefully in the numerical methods chapter, I gave you for the stability of this method. For stability of this method, I told you this step size has to be 0 less than or equal to h less than or equal to 2 by mod lambda. Correct? If you can check PYQ series, this question we have discussed, and of course for a different differential equation. But of course, in the comprehensive series, I have given you this condition for the stability of the Newton forward Newton scheme, forward Euler scheme. Correct? So here, if you see the differential equation that's given is yi plus 1 minus yi divided by h is equal to minus pi times yi. So here the lambda value is minus pi if you compare. So for the stability of this, 0 less than or equal to h less than or equal to 2 by modulus of lambda, which is modulus of minus pi. So you can just get the step size limit as 0 less than or equal to h less than or equal to 2 by pi. Anyhow, you can just remove the equality sign here, because if you take the step size is equal to 0 exactly, there won't be any increments. So we can write something like this. Okay, so this is what we get as the limits for this step size h for this given Newton's forward Euler method. Next, let's go for the next question. Yeah, there is one question from aptitude also. There is one triangle. Let me use this sketchings for a while. So there is one triangle in which you have a right angle triangle, and this is radius r, this is also radius r, and this is the triangle that's given, and they have given you the area of this triangle is how much? Area of this triangle is 50 centimeters square. So this is given as a right angle triangle. So if this is a right angle triangle, then definitely the area of this triangle is half times of r square, which is equal to 50, which implies r square is equal to 100. So this is what we have. So let us keep this centimeter square, of course. Then what is the area of the circle? Area of the circle is pi r square, and you get the value of r square from here, which is pi times of 100 centimeter square. Okay, so it's a simple apt equation that you can solve with basic intuition on geometry. So area of this triangle is nothing but 100 times of pi centimeter square. Then we have one question from resistance spot welding. So they have given you some thickness of the welds, which is 1.55 centimeters thickness of the sheets to be welded, and the current that they passed is 10 power 4 amperes, and the time they have taken is 0.25 seconds for the pulse. Then they have also given that volume removal rate of the nugget is 70 mm cube, and specific energy that's required for cutting or for welding is equal to 12 joule per mm cube. This is what they have also given, and this volume that's being removed is mm cube per second, I guess. Yes. Then resistance is 10 power minus 4 ohms. So this is what we have. So if they have also given, yeah, this is the data given. They are asking you for what is the thermal efficiency of this heat input. Correct? So what is the efficiency of this welding? So for the given heat supplied. So if you quickly perform calculations, thermal efficiency of this welding is nothing but, actual heat that supplied is how much? Actual heat that is supplied is 840. So we can write 840 at the denominator, and if you perform some, 840 is the actual heat that's required for the welding, and they supplied 2500 joules. So the resultant is 33.6%. So 33.6% is the efficiency of the welding process, or the heat supplied in the welding process that's used for the welding. So 33.6 is the answer for this. Okay, it's a very simple calculation. Actually, how much heat that we supply is equal to I square RT. So I, T, and R. So you can calculate what is the exact heat input, and of course what is the material removal rate or the energy required for volume. So volume is also given. So you get what is the power required from this time. Power required from this thing, and power into time will give you the energy again. How much energy of the supplied energy is spent for the welding or the heating. Okay, so this is basically a simple question. Next, we have the cone hanging like this, and what is the deflection at the midsection? Suppose if this total height is h, what is the deflection at this of this middle plane, h by 2? Correct. So we know if you apply the simple Hooke's law, delta is equal to integral 0 to x or 0 to h by 2, till which you are taking px into dx by ax ex. And of course, for getting this px, you need to integrate, because if you take any section, then the load acted upon this section is the weight of this small portion. So you can integrate to get the value of Px actually. So if you perform the final calculations, your delta that you are ending up with is WL cube by, okay, let us write in terms of specific weight. So that is equal to gamma into L square divided by 8 times of Young's modulus is the deflection that you have at this midplane at a distance of this h by 2, x is equal to h by 2. Okay, so gamma L square by 8E is the correct answer. Again, I'm repeating, I'm just giving you the key for many of the questions because people are waiting for checking the key actually. So next, we have one more question. A cantilever is subjected to a uniform bending moment, M. Then what is the deflection at this mid of the beam, L by 2? Okay, so at L by 2, here, what is the deflection? Simple, look, if you try to draw the bending moment diagram for this, then the bending moment diagram looks something like this. It's a rectangle, and of course, this is of length L, correct? Now, this is the section that you have, and you know, generally, if these are the points A, B, and C, then if you want to write delta B minus delta A, this is equal to moment of this area about this section, correct? So, this section which is of length L by 2 has centroid located at this point. It has the centroid located at this point, and of course this is at length L by 4, correct? So now this is equal to area of this is which is M by EI. Of course this should be the M by EI diagram. So M by EI into the length is L by 2 into the distance from this section to the centroid is L by 4. So if you perform this calculation quickly, and you know at the free or the support the deflection is 0, so delta B which is at the midspan, this is equal to M L square by 8 EI is what we have as the deflection at this point. Okay, so this is the moment area theorem, first moment area theorem. So you can just get the value from this M L square by 8 EI. Okay, and I think that should be the answer. Let me check quickly. Okay, so yeah, ML square by 8 EI, that's okay. So again, there is one question from engineering mechanics, simple application of static balance. So now you have two spheres that got entangled between. So there is one more sphere, something like this. So if these are two spheres, and if the weight of the spheres is also given here, then what is the contact reaction basically? So if you try to separate them, or if you try to draw one block, then we have some contact reaction, the weight of the block acting, and of course let us suppose this is A, then if I am writing about A, there is also the contact reaction at this point. But of course this is a concurrent force system, correct? So here you need to determine this angle, and if you solve this angle, it comes like sin theta is equal to this should be 250. So sin theta is equal to 4 by 5 and cos theta is equal to 3 by 5. This is what you will be ending up with if you perform some calculations, because this channel width is given. This is 400 mm. From 400 mm, I would like to show you quickly how this is 4 by 5 and all. This is 125 and this is also 125. So which means the vertical distance or the horizontal distance between these two supports is 400 minus 250, which is 150. And of course, you know, this length is 250 because this is 125 plus 125. So if you write cos theta from this triangle, look, if you frame a triangle here in the dotted line, if this is theta, then cos theta is equal to 150 divided by 250, which is 3 by 5. So that's how you will be getting this cos theta is equal to 3 by 5, sin theta is equal to 4 by 5. So if you apply the simple static balance or simple sigma fx or fy is equal to 0 in any directions, then you know this contact reaction r times sin theta is equal to your weight of the block, and this is given as r into sin theta is 4 by 5. So W is 100 newtons. So you can just cancel the things and you'll be ending up the reaction as 125 newtons. Is that given in kilonewtons or no? It's given in newtons. So 125 newtons is the correct answer for this. Okay. Anyhow, this is a simple equilibrium that you need to apply for this question. Next, let us go quickly to the other question. Yes, there is some material which is stretched beyond its elastic limits. In the stress strain curve, you could see some curve or some property of the material like this. So basically, there is some stretching of this material, and of course, when you trace back, it traces along this path, which is something parallel to this initial portion, correct? So definitely, if this is the strain, total strain that occurred 0.03, and if this is 0 and this value is given as 0.01, which means you can obtain one data very clearly from this equation, and this is also given 200 megapascals. Yeah, 200 megapascals is the value. So now one thing is very clear, when the material is strained to 0.03 and when you are trying to unload, see, this is loading curve and this is unloading curve. So when you are unloading, there is a reset of 0.02, correct? So this is the reset that occurred, which means this is the elastic strain, because elasticity is the property that when you trace back the load, that points gets traced back within the material. So 0.02 is the linear strain or the elastic strain. So elastic strain is equal to 0.02, but there is a permanent set of 0.01. So plastic strain is nothing but 0.01. This is the correct value or the correct answer for this question. So the option involving such values of 0.02 for plastic, so 0.02 for elastic strain and 0.01 for plastic strain is the correct answer. Next, there is one question from this braking torque. So there is basically one drum that is rotating, and of course here there is a shoe, and there is one lever on top of this. Okay, there is hinge here. Okay, also there is some support here. That's also fine. Next, so dimensions are given, and of course drum material, shoe material, and all is given. Mu is 0.4. So if you apply the simple static balance again for this lever, some load is also applied here. So this is the question that I'm talking about. They are asking you for the braking torque. So if you apply the static equilibrium of this lever, then definitely you'll be getting the contact reaction N and mu N. N, and of course you will be also getting mu N acting on the lever. So if you get the magnitude of mu N acts, if the drum is rotating in this direction, then definitely mu N starts acting here. So definitely the torque acting or the moment that's acting is this mu N into this radius of the drum. So mu N times R, and if you perform the calculation correctly, you should end up with something like 200 Newton meter. So the braking torque is 200 Newton meter is what we calculated finally. So the answer for this lever shoe drum question is 200 Newton meter. Okay, next, let's go for the next question. So in the springs, they have given you, if this is the circular cross section, or let me use a circle for defining the case. So if this is what you have, then they are asking you for this stress distribution. This is not symmetric. You can see here center is somewhere here, but the shear stress distribution that's happening here, let me put this out a bit carefully. So okay, so fine, this is the stress distribution that we have, and of course this is not the case of, mu N is opposite direction. Look, I'd like to tell you, if this is the drum is rotating like this, so the point or the velocity in this point is like this, so definitely the friction should act in this direction on the drum, mu N. Yes, correct. So I have marked this direction, fine. So this should be in the reverse here, mu N, correct. This is the correct direction. Yes, Sai Krishna. Okay, so this is the question. So this is the effect of direct shear plus torsional shear. Correct, because if curvature effects is also involved, this line couldn't have been straight. So direct shear plus torsional shear effects is the correct case that matches with this. Okay, so direct shear plus torsional shear effects is the correct this thing for this. Next, they have also given some question on queuing theory. And in queuing theory, this arrival rate is 12 per hour, and departure rate is also given, which is 15 per hour. Correct. So they are asking you what's the length of the system, and length of the system is nothing but, you can see clearly, this rho is equal to lambda by mu. So 12 by 15, which is 3 by 4. Sorry, if you cancel the table, this is 4 by 5, which is 0.8. So length of the system is nothing but rho by rho minus 1 or 1 minus rho. So 0.8 divided by 0.2. So there will be 4 systems or 4 customers at any given point of time, at given time. So the actual length of the system that you could guess is 4. Then they are asking you for the quick return mechanism. Of course, we have some big diagram, but of course, I just want to reveal the answer for the Whitworth or the Whitworth quick return mechanism or quick return ratio. The value is 2. Actually, you can perform this calculation. Some dimensions and links and the dimensions of the links are given, but of course, you can just calculate by using simple analogies, and you can get the quick return ratio as 2 finally. And also they have given one question from this project evaluation review technique. So there are 4 activities A, B, C, D that are to be done, and of course the duration for this is given as 6, 11, 8 and 15, and of course the variance for each of this activity is also given. This is 4, 9, 4, 9. Okay, so the average time. So the average time that we could take here is 40 days if we sum up all these things. So they are asking you exactly for 40. So that's a very much simple case. So they are asking for the probability of 40 days, and also you have the actual time of 40 days. Then definitely if you apply this normal curve, then if this is the 40, which is the average or the mean that the project is expected to complete, so this is the area which comprises that the project will happen before 40 days. So definitely this area in a standard normal distribution curve is 0.5. So you could clearly say this probability of getting the project done in 40 days is 0.5. Okay. XC की आंसर की हमें मेमोरी बेस्ड क्वेश्चंस डिस्कस किया लक्षिता. Okay. Next, let's go for this average center line roughness. So the answer is 1 for this average center line roughness. Let us average center line roughness. So this answer is 1 because you know the average is nothing but modulus of roughness values, which is y1 plus y2 plus y3 plus y4 divided by n. Few people may end up with 0 if you forget this modulus sign, but of course the deviation is actually the magnitude is what you are measuring, so you will take a modulus. So L by 4 plus L by 4 plus L by 4 plus L by 4 and 1 plus 1 plus 1 plus 1 divided by L. So we get 1 as the final answer in this case. Okay, so the average center line roughness value is 1. Next, let's go for the next question. So there is some welded joint that's given. Of course, in a rectangle, if you try to look at the cross section, first of all, let me draw the beam. So there is some beam on which a direct load of or a transverse load of 2 kilonewtons is acting, and of course you have this weld along here. So this is your weld that you have, and this weld, if you try to generate here again, in side view you can see the two portions of the weld sharing this load. Okay, so this is what given, or whatever, some dimensions are given. Finally they are asking you for the leg of the weld, leg thickness of the weld, okay, in mm, that too. Okay, so in mm. So finally, if you apply this bending moment equation, this flexural equation for bending, and of course some direct shear is also acting. So if you take the net sigma b max as square root of sigma b by 2 whole square plus direct shear effect, which is tau square. So this is what you can do finally. And of course, if you perform this calculation, or this is not sigma max, this is tau max, because this is the maximum shear stress that's acting, in plane shear stress. So this is tau max, and tau max is also given, and sigma b and all you can calculate from the dimensions. And so finally the value that you'll be getting for this length is 6.656 mm is what you are getting for this. Okay, so h is equal to 6.656 mm is the leg size of the weld for maintaining this stability of the system. Okay, next, there is one question in a cantilever. So on a cantilever, basically there is some variation of the load, right, from 800 newtons to 1600 newtons. So this is what we have. Correct. So 800 newtons to 1600 newtons, and of course the cross section of this beam is also given, which is something like this is 20 mm and this is 22 mm. Then I think our diagram should be in the other point. Let us reframe the diagram. So yes, this is 20 mm, and of course this is 22 mm. So we have these things. So they are asking you for what's the factor of safety assumed using evaluated using this modified Goodman's theory. So definitely, if you calculate this values, and yeah, Goodman theory will give you a factor of safety of 2, because you know in Goodman's theory we have this stress amplitude, mean stress divided by sigma yield stress plus sigma amplitude divided by the endurance limit is equal to 1 by f of s, and enough data is given in the question that they have given this load and this cross section values, so you can calculate what is sigma maximum, sigma minimum. So if you calculate what is sigma max and sigma minimum, you can calculate what is sigma mean, and of course the amplitude also, sigma amplitude. This is what we can calculate. So if you calculate these two things, and these two data is given in the question, so you can just calculate 1 by f of s, and you will end up with the value of 2 for f of x. Okay, so generally, next, so if this is the dielectrics, this is genetics of the cone of the any material. So if this is genetics, and if this is the dielectrics, then what is the surface that is getting generated? Of course, this is the common case that you see in a lathe machine. So whenever any surface is available in this genetic form, and if the tool movement is in that case, then you will be ending up with a cylinder, because you can see whatever might be the dimensions here in this case, as the tool is moving, it starts cleaning up all the material, forming a cylinder. Okay, this is the general case that you see in any lathe machine generally. So this is cylindrical in shape. Next, so finishing jobs, of course, first you will be doing the drilling to get some hole size with some roughness. Then after drilling, you will perform some boring operation so that your surfaces get smoothened, and of course here By this time, you'll get a decent, good surface finish. But of course, for high finishing operations, we'll also perform this reaming operation with a reamer. Correct? So this is the correct sequence. So drilling, then you perform bowing, and of course, then you perform this reaming operation. So this is a super finishing operation. This is a finishing operation, and this is actually the machining operation that you perform to take out the material. Clear? So this is the correct sequence. Next, we have few more questions. So there is a cantilever, there is an overhanging beam actually. So there is some overhanging beam. This length is given as 200 mm, and this length is 100 mm. So this is the beam that is with us, and of course there is a uniformly distributing load on this beam, and this capacity is 20 kilonewton per meter, and this total beam is of span. This is 2000 mm. Yeah, this is 20 kilonewton meter, and this is 2000 mm. Anyhow, and this is 1000 mm. So anyhow, if this is the case, then after performing the final calculations, you end up with the answer of 250. Newton per mm square is what we have for the maximum bending moment that's getting induced in this. Next, during the machining operation, they are asking you for the cutting force Fc, correct? Or shear force Fs is what they are asking you for. This shear force is what they are asking you for, and they have given enough data in the question. So the magnitude of the shear force that you will be getting is 408.15 newtons. Okay, some rake angle is given 12 degrees, and of course uncut chip thickness, cut chip thickness is also given. So 0.75 is the uncut chip thickness, and of course cut chip thickness is 1.5 mm. So we can find what is the chip thickness ratio, which is 0.5, because 0.75 divided by 1.5, and of course for the shear angle we have tan inverse of r cos alpha divided by 1 minus r sin alpha. So we'll get what is the shear angle. Then if you apply few other things like the relation between the forces, then we can get this finally shear force as 408.15 newtons. Next. So we have few other questions also. Yes. So there is some rollers question that's happening. So basically they have asked you for there is two pair of holes and there is one material that's getting rolled in between. Correct? They have also given you the reducted diameters and everything. D1 or H1, H2. Few times it's represented by H1, H2 in few books. So this can be treated as H2, and they are asking you for what is the force required to maintain this rotating flow. And of course they have given, force required for this. They are asking you for what is the force required to maintain this rotation, to maintain this rolling happen. So F is equal to sigma B bar or sigma flow stress, you can write, into width of the plates into this length of contact. You can write length of LC, length of contact you can write, and this F is equal to K by n plus 1 into epsilon power n into face width of which is the width of the this block into this contact length is nothing but root times of r into delta h, where r is the radius of roller. Radius of roller. Okay, so n strength coefficient exponent is given. How much is this? 0.2, and K is the strength coefficient, so which is 300 megapascal. So we have few things to calculate here, and of course the H1 value is given. H1 is 20 mm. So this H1 is 20 mm and H2 is 18 mm. So this is what we have, and of course if you can substitute all these things in this, you can get a value for this. Next, in 41, there is one more question. So basically there is some member, some prismatic member with sections merging together. So this is basically divided into 4 sections: P, Q, R and S. Correct? This is what we have, and of course they have applied some loads here, which is 25 kilonewtons. And then this is 20 at this point, and of course all the values are in kilonewtons. Next, this is 15 that's being applied at this point, and this is 10 kilonewtons that's being applied at this point. So they are asking you what are the sections with maximum and minimum stresses. So if you just apply quickly the static equilibrium of all these sections, and then you see an extra of 25 kilonewtons here. So this is 25 and this is also 25. Look, at this point there is a net effect of 20 kilonewtons on the right, but if there is already 25 that's existing to the right, we have to balance this with a 5 kilonewtons to maintain this joint. So this will also be 5 kilonewtons. So if this is 5 kilonewtons, you see a net effect of 15 in this way. So there should be again 20 kilonewtons in this to create a 15 kilonewtons net effect. So this should be 20 kilonewtons again, and of course this is 10 oriented, so this is 10 in the opposite direction. So we have some tensile load that's acting, and this is the configuration that's acting on all these 4 blocks. Out of this, you know, the area is constant for all these 4 blocks. So maximum stress will be that block which has the highest load acting, so which is this portion, so which is RS, and of course minimum will be the portion which is having the lowest load acting, that's in this 5 kilonewton, so this portion is QR. So QR and RS are the portions in which the load or the stress is maximum and minimum respectively. Next, there is one question from aptitude also. A circular pie chart is divided into certain portions where of course the component C2 contains 20% of the 5% of the total population and C5. So basically it's divided into some populations. This is C1, C2 and so on, C3, C4, C5, C6 and all. So some components got divided into, but of course the points of importance from this data is 20%. So they have asked about some executives and non-executives in this case. So in this case, if you perform the calculations, the total number of executives in the company, C2 and C5 together, this is equal to 1900 is what you are getting if you calculate the things correctly. So 1900 is the value that's it gives you the total number of managers, total number of executives out of this 2 companies, C2 and C5. So there is one question also from seating arrangements, PQRST, and the answer for this, I'm not giving you the detailed solution again. This is 16. Total number of possibilities are 16 in this case. Okay. So Apnil, so most probably I'll get 62 plus marks in GATE mechanical set 1. Is there any chance of getting into top IITs in industrial engineering branch like IIT Bombay and Calcos? Swapnil, there are a lot of things that matter depending upon the number of applications, and some category also plays into role. So definitely you can check with the last year intake and all, because every IIT after the closing of its MTech admissions for that year, they upload the lowest GATE score for which the candidate has been admitted to them. Okay, so if you, for example, if you want to go to IIT Madras, then you can click MTech IIT M MTech 2020, you can click, this is a website. So if you go into this, then definitely you will find one PDF there, lowest GATE score of the last candidate who got the seat. So if you click that, you have the category wise scores for which you can get admitted. Okay, so you can think accordingly. Next, 45. Again, there is one question from Form P and Form Q. Some goats, hens and ducks were shifted from one form to another form. Then no, I don't teach in an academy. Abdul Basit. Anyhow, fine. So the answer for this is 10 is to 21 is to 26. Final answer. Okay. So please make a note. This is the answer because Swapnil, every IIT has this. Every IIT has its own MTech admissions website. So please log on to. You need not log in. You just visit the website. You will find a PDF like the lowest GATE score of the last admitted candidate. So you can decide accordingly. Clear? Fine. Next. So Form P and Form Q are given. Some goats and ducks, hence were shifted here and there. So finally, if you take out the answer, it's 10 is to 21 is to 26. Next. Yeah, there is one person coming out of a house. So there is one person that is coming out of a house, and if he stand, he found his shadow to the right. And this is morning. So if this is morning and if the shadow is in this direction, definitely the sun has to be here. And in the morning, if sun is here, then this is east. Then if this is east, then this is your west. So which means this is your, sorry, I think we have made something different. So the person, as soon as he comes out from the house, this is right. So the house east is in this direction. So similarly, if east is in this direction, then west is this, north is this, and south is this. And if the person is coming in the face, which means this is the south direction, so this house is faced towards south. Because when the shadow is this way, sun has to be here, and definitely if sun is here in the morning, this direction is east. Then definitely the house is in the direction of south. Okay, that's the question. Then there is some question from operations, like basically this plus stands for minus, into stands for divided by, then this triangle stands for plus, and this inverted triangle stands for into. So they have asked you some basic operation like triangle 2, this thing 3, delta of 4 into 2, this 4. So if you perform this value totally, you will get 7. Okay, 7 is the answer for this question. And of course, this is south facing house. Next. Yeah, I think those are the questions memory based that we collected from our students, but it got a bit delayed because the data that came to us is a bit slow from our students. Actually, there are limited number of attempts, but of course this is the PDF that has detailed solutions that we made for giving to the students. So definitely you can find this in all the channels of Engineers Hub, like Telegram, Facebook, and everywhere. And also you can just find it in all the WhatsApp groups of Engineers Hub and also all the Telegram channels of Engineers Hub in no time. Okay, thank you all. Have a nice time. I hope you performed very well in your GATE 2021 and you will be ending up with some career like in IITs or in some PSUs. Okay, and one suggestion I would like to give finally, because many students after getting the low GATE score, they wait for some time, 2-3 months. Please don't do that. You have a lot of exams, a lot of companies, a lot of PSUs that recruit without the help of GATE. So keep on preparing. Definitely you'll crack one exam which is taking you in without GATE examination or without GATE score. Okay, my sincere suggestions, you please keep on preparing from today itself. Don't take a leisure of 2-3 months. HMT thermal conductivity question. Yeah, there is one question from thermal conductivity. Yeah, I remember this. Basically, there is one wire which is giving out some heat at 5 watts per meter, correct, in the case. And of course, at that time, the temperature of this outer surface is 75 degrees Celsius, and of course, this is 25 degrees Celsius atmosphere. In the second case, this is covered with a insulation. Or else let me draw the same color for the pipe or the wire, and this time along the wire there is also some insulation, correct? There is some insulation that's acting. There is some insulation. Yeah, this is some insulation, and of course this is the center line. So this is the radius of the wire and this is the thickness of the insulation. This is what they have, and they are asking for what is the insulation or thermal conductivity of this insulating material. Look, gyroscopic couple is nothing but I omega omega p, and you know I is given 10. I don't remember the exact values in exam, but of course all these three are mentioned in the exam, so it's just multiplication of all these three values. Okay, some propeller shaft and propeller is given, and then I is combined moment of inertia for all these things is given, which is some 10 kg meter square, and omega is something given, it's 5 or something, and again this precision angular velocity is also given. So I times of omega into omega p is the gyroscopic couple. You can just multiply all the three values that's given in the question. Okay, and that's the answer. And anyhow, so for this question, it's very easy. You know, heat transferred in this case is 5 watt per meter. So total heat reflected in this case, what's the total heat that's need to get out of this basically wire to maintain the equilibrium of the thermal equilibrium of the system? 5 into length, because if it's 5 watt per meter, then the total heat that getting out is 5 into length, which should also be equal to convection heat loss from this pipe or convection heat loss from this wire. So if H is the convection, then 5 dl is the area to which it loses heat, and the difference between these two things is 50. So this is what we have. L gets cancelled, 5, 10, and of course we have H is equal to diameter is also given. I don't remember the exact value, but I think diameter the radius of this is 1 mm or 1 centimeter, 1 mm I guess. So radius of, since it's a wire, generally wires are very thin in general. So and 5 watts is also a very bit slow value. So this is what we have. So R value, this is what we can have here. So H is equal to 1 by 10 pi d. This is what we'll be having. Of course, you need to substitute the diameters and all. So then see here. Then this insulation is also given, and this temperature this time is 55 degrees Celsius. That's what it's given here. This temperature here is 55 degrees Celsius that's given, and of course this temperature remains 25 degrees Celsius atmospheric temperature. Then we need to find this temperature, and if you calculate in exam for the given values, you are getting it as 50, and then if you apply heat transfer through this is equal to 2 pi KL temperature difference by ln R2 by R1. If you apply all these things, I guess you are getting something in between. This K insulation is something in between around 0.11 watt per meter Kelvin, something around this. Okay, so this is what the thermal conductivity that you are getting for this insulation, and of course insulation materials have very low thermal conductivity. Something less than 1 could be a reasonable answer. Okay, so anyhow, these are the questions, and one important suggestion I want to give to all of you. Please listen. Whoever got the low GATE score, please don't worry, because I am telling you, in IITs, many of the IITs, almost all the IITs, along with the MTech program, there is one more program which is called the MS program. Okay, so after generally MTech program will be given to all the category students who have some high GATE score, but of course there is one more program which is called the MS, which is research oriented. Okay, in MTech, your MTech program is basically course oriented, so you'll be you will be undergoing some 12-15 courses and a bit of project in the final semester. But a research program which is MS is of such kind where you need to finish some 3-4 subjects, and also major focus is on research. The stipend for both are same, and the time duration for MS is 6 months above on an average 2.5 years, and for MTech it's 2 years. So if you have a bit of lower GATE score, please don't worry, you can apply for the MS program and you can get a master's degree from IIT. Clear? Thank you. Have a nice time. Very soon at 12:30 am, we'll come up with the key for the afternoon session because things are going on outside. So please stay tuned on this channel. So in 20 minutes at 12:30, we'll again come back with the key for the afternoon set. Okay. Thank you all. Have a nice time.